Hello guys, this is Prime Concept. In this video, we want to look at image formation for our concave lens. For our concave lens. Another name for our concave lens, like we mentioned, is what? A diverging lens. We have considered image formation for our convex lens, and we looked at about 6 separate positions. So in this video, we want to consider the image formation for concave lens when our object is placed. Now, when your object, irrespective of the position you place your object, your image would always be formed at a certain position which does not really change. So it means that for a concave lens, we'll be considering only one diagram. Unlike our convex lens, we looked at about 6, right? Now, same rules that were applied in convex lens are also applied here. So let's consider when our object is placed somewhere. This is our concave lens. Remember, this is our concave lens. I'm drawing it very large so that you can see, and every point will be really obvious to you. It looks like my hand is always bending. So say this is what I have, and I'm going to call this point F1, call this point 2F1, call this point F2, call this point 2F2. So I want to place my object anywhere, just anywhere. So because anywhere you place your object, your image is formed on one particular side, it doesn't change. So this is my object, right? Let me denote it with O. So if I follow the rules, I have a parallel ray like this. When it hits the center of my mirror, because this is a diverging lens, what will actually happen is that the ray will do what? Diverge. But it will appear as if it is diverging from, so it will appear as if it were diverging from your focal point. So it will appear to be diverging from your focal point, right? Yes. Now, if you consider another rule, say you are passing through the center of your lens. Remember, it will go through unrefracted or the undeviated. So you have this, though not very straight, but we can manage this. So we have this, it will go straight, unrefracted, undeviated, right? So if you consider the point of intersection of your refracted rays, you see that this is where both of them are intersecting. And of course, this is where your image, I, will be formed. So if you look at this very clearly, you can deduce the properties of this image that is formed. And let's list those properties. And one of the properties of the image is that image is formed on same side as what? Object. Image is formed on the same side as what? Object. You can see it. If your image is formed on the same side as your object, it obviously means that your image is what? Virtual. Your image is what? Virtual. Then number 3 point we can see is that our image is erect. When you have a virtual image, you expect that image to be what? Erect. So our image is erect. And finally, number 4, our image is really diminished, or image is smaller than the object, which you can see image is smaller than the object. So I believe these properties and this concept is very clear to you. So this is the only scenario or situation we have for our concave or diverging lens. So I believe we have been able to do justice to image formation on your convex and your concave lens. In my next video, I'm going to look at the derivation of lens formula. We did for mirror and we derived mirror formula. So in my next video, I'll show you how we can derive the lens formula, and then we'll look at the formula for magnification of a lens, and then we'll begin to analyze these things mathematically. So if you have followed me up till this point, and you are not yet subscribed to my channel, please do well to hit the subscribe button, like my videos, comment, and share with 10 of your friends so that they can also benefit. Thanks for always supporting me. This is Prime Concepts.